Good evening. The purpose of our webinar tonight, as Mike mentioned, is to show some of the activities that are available through the Math Nspired website that are aligned to the Common Core standards that are focused on data and probability and statistics. And we're going to be looking at how you can help your students improve those skills in those areas. We're going to look at ways that we can use multiple graphical representations to describe data, and then we'll also be displaying some of those free online and Math-inspired resources.
Thanks, Blake. And Denny's going to discuss our expected outcomes tonight. Denny?
Our plan is to help you use random sampling when we generate data sets. We're going to help students learn how to draw inferences from these sets. We also want to take a look at univariate and bivariate data and analyze that data. And then we hope to encourage you to stay in touch with a variety of mechanisms that you can learn more about how technology, TI technology in particular, can help you and what things are coming up in the future, what kind of events we'll have. All right?
Thanks, Denny. Blake, if you'd like to begin sharing your desktop. As Blake is sharing his desktop, you'll notice that the Q&A window and the chat window, which used to be located on the right side of your screen, have now moved to the top, and they're underneath that green floating toolbar. So if you need to ask questions or you'd like to have some questions answered live, and we hope you will, feel free to ask any questions to all panelists using the chat window or the Q&A. Blake, it's all yours.
Thanks, Mike. The first activity we're going to take a look at is one from the middle grades Math Inspired section on statistics and probability. And the title of this activity is called 1 Year Makes a Difference. And what we're going to see in this activity is really multiple representations of univariate data. And so to start off, the students, and I'm going to pull up the student sheet for this activity so you'll kind of have a context for this. But the data that the students work with in this activity is centered around this information in these two tables here, and then there's also some additional data that shows up on some of the other pages in the exercise as well. But essentially, we're going to be working with data that's pre-built into the TNS file or the Nspire file. So this is not something, this activity doesn't require the students to actually go out and collect the data on their own, although you could do a similar activity with that. But in this case, the data is actually already here for us. And so what we're going to start off by looking at is how we can represent this data. And so to get to our next page, of course, right now we're looking at the title page of the activity. And to get to the actual page where the students would actually start to look at the data, we can press Control, and then the right arrow button is our next page, is how we advance the page on the TNS document. And so you'll notice here we've got some data points, but at this point, we really don't have any meaning assigned to these. And so what I'm going to do is that I'm going to access this option down at the bottom where it says click here to add variable, and we're going to add the variables that we will be working with in this activity. And I'm going to start off by adding my 7th grade bench press data. And when we do that, it's going to put it in a line plot. And I'm going to go ahead and add my 8th grade data. And let me do this here by doing it on the keypad. So I wanted to add my variable down here. I hope I can do this with my computer software. it doesn't look like I'm going to be able to do that. So I'm going to do it with my keyboard here on my computer. Essentially, we're going to do a right click, and if you're using this with the handheld, the steps for a right click function on your handheld is Control Menu. That gives you the same option as if you do a right click on the software. We're going to add an X variable, and we're also going to, at this point, add the data for 8th grade. And so you can see here the file actually splits the data apart. We've got 7th grade at the top. We've got 8th grade at the bottom. And again, this is a way to organize the data. We can start to see some trends here, if you will. But in order to really be able to analyze this, we need to be able to see some additional representations. So let's start off by looking at a box plot. To do this, we can press the menu button, and our options, since we're dealing with a data and statistics page, this is the menu that we get on a data and statistics page. And the first option there is plot type. So we want to switch this from a line plot to a box plot. And I'm going to just press enter. And so you can see now it's taken that data and it's put it in box plot form. So what is this?
Hey, Blake?
Yes.
Hey, Blake, would you move your cursor over those whiskers?
I was just going to get there. Thank you for bringing that up. So what Denny is saying is for me to move my cursor over these whiskers. And as I do that, notice what's happening. Okay, it's giving me some values here. And as I move over the other part of this graph, this box and whisker plot, it's also giving me the values for the median, third quartile, first quartile, and then for the upper quartile as well. And then out here on the 8th grade, you can see we also have an outlier. So we have two examples here of different types of box plots, one with outliers and one without outliers. And again, I'm displaying those values simply by clicking, not really clicking, I'm sorry, not clicking, but just mousing over, moving my cursor over the box plot. So it's pretty nice for your students to be able to see that and be able to associate those values and also be able to relate that down here with the number line representation and to be able to compare them that way. Okay.
What about another kind of graph? Is it possible for us to make another kind of graph?
It is. We can certainly do that. And I'll tell you what, let's go to the next page. So I'm going to do Control and then the right side of my touchpad. And I'm going to follow the same process that I went through. Again, we see the data here. It's just all of our data points. We really don't have any meaning with this data right now because we don't know what these points represent. But if I click down here and add my variables, there's my 7th grade. And obviously, this is a different set of data. This is, in fact, the height of 7th graders and 8th graders. And we still have this line plot now. And what Denny was saying, well, can we generate another type of plot from this type of representation? And we can do that. Again, we press Menu, and our first option in our data and statistics page, or our data and statistics menu, is plot type. And now I'm going to generate a histogram. Now, what's the benefit to generating a histogram, and when would we use that? Well, as opposed to the box plot that we saw here, it may be a little bit harder for our students to determine interquartile range with the histogram, although they can't do that. But what we can look at here are the bin sizes, and we can actually change that on our histogram. That's under Menu, and when we go to Plot Properties and go to Histogram Properties, our second option there are our bin settings. And I'm going to set this so that we have equal bin width, and I'm going to change this to 0.5 or 1/2. What this allows us to do is ask questions around the intervals of the data and get our students to describe what happens when we change the bin size. Does it affect the number of bars that show up? What happens between the spacing of these bars? Why does the spacing increase or decrease? And it allows us to have the discussions around the clustering of the data.
Here we also have an example where there are gaps in the histograms. And sometimes
exactly.
People mix that notion up that histograms don't have gaps between them, but bar graphs do. And in this case, we have a histogram with gaps.
Exactly. Good, excellent point, Denny. And that's something that our kids very quickly, that's a very easy misconception for them to have. What he's talking about is having the space there. This is a wonderful way, I can't stress it enough, it's a wonderful way for you to have the discussion and really get your kids to talking about what does the width of this bar mean? Is it indicating just one value, or is it indicating a range of values? And if so, what is the size of that range? And then we can do things like come back to our plot property, and let's just change that. Let's change the plot properties of our histogram. Let's change the bin settings. And instead of 5, let's make it, instead of 1/2, let's make it 3. How did that change the representation of the data? How is the data clustered now? All right. For the rest of this activity, the students are doing some similar exercises with some additional data sets. And on this one, let's see. Let me remember.
That looks like the shuttle run. Yeah.
Yeah, that's what it was. The shuttle run. And again, we go through the same process of clicking down along the bottom of the screen to add our X variable, and then right-clicking to add another X variable. And I believe with this part of the activity, the students actually answer some questions. And what they do is they first create a box plot, and then they switch this data. And this is really kind of nice for them to see the animation, to go from the box plot to the histogram with the same set of data, because that also allows you to have the discussion about which representation is appropriate for answering different types of questions around the data. I really like the way that we can take the same set of data and very quickly switch the type of representation with that same set of data. Denny, can you think of anything else to to touch on with this?
No, I thought you hit quite a few of them. Here we have 2 data sets that are related to their shuttle run times, and it looks like we could ask lots of kinds of questions of our students to do analysis of this data in this format, and we could do the same in the other format, and it's easy to jump back and forth. So I think you've showed those capabilities, and it's up to teachers to pose those questions.
Okay. Then you want to move on to the next activity?
Sure. I'm thinking lines of fit makes sense now.
I think so too. So let's go ahead and open that one up.
Okay.
And I'll drive, and you be the captain here.
Okay. Here we have one where we have bivariate data, x, y coordinate kind of data, and we want to do what we used to call spaghetti lines. Imagine graphing some data on a piece of paper and then putting a piece of spaghetti down on it. Well, let's take a look at this lines of fit. Move over to the next one. Here we have data that isn't perfectly linear, but it looks like it's something that we could adjust. And what we're going to do is Blake, would you move the cursor over and go toward the middle of that line and see that compass rose? If you click and drag down, let's see what happens. We see the line change. It looks like the slope is staying the same, but the intercept is the thing that's changing. Let go of it right there when you feel like it's somewhere you'd like it to be. And would you move maybe up to the northeast corner of the screen? And look how the compass rose changes. Once you get away from, let's call it the middle, the compass rose changes. So now click and drag ever so slowly down. Now you see how we can tilt this piece of spaghetti. That's what we used to call them. Move it back up and kind of fit it so that you think it describes this set of data, taking into account they're not all going to fit on the line. What do you think, Blake? Notice he's moving to the center, and the compass rose appears again. That allows you to move it up and down. And move down to the southwest corner, and you see that comes up again. This is our rotation. It allows us to turn the line and change the slope. Are you happy with that? All right. The notion here is students gain a great deal of information from playing with this, and I mean playing in the best sense of the word. They're using a tool to help come to understand some set of data, and this allows them to come up with the equation of the line without throwing regression in, which certainly isn't a middle school concept. But they can manually fit this line very easily, and the TI-Nspire allows that to happen very quickly, and students get pretty good at doing this right away. They'll all want to know if they have the right answer, when in fact there's a whole family of good answers for this kind of problem. Blake, would you show us a position that doesn't really make a lot of sense for this data? And folks, to me, where he's moved it is all the data is below this, and it shouldn't be there. So students are really good at finding lines of fit manually. And let's talk about the data just for a second. We have math and verbal scores on exams, and there looks like there's some kind of relationship. Thank you, Blake.
You know, I'm noticing something about the numbers on those axes. It doesn't start at 0.
Ah. Do you want to change the axes, Blake, so that a good friend of mine, a science teacher, said math teachers like to show their axes, and science teachers don't worry about it so much. So let's see what happens if we change that. Go ahead and click down there, or are you going to drag? Choose one of those two options. As he pulls this, we get our x-axis, the 0 to show. Now tug on the other one. See how interactive this is and how easy it is for him to change this, to morph this? Pretty soon we'll have our origin showing up at the intersection of those two lines. Notice how the data is all clustered up in the northeast corner. So it wasn't such a bad idea after all. And we can also see why some of those lines would allow for us to have a negative intercept. Blake, would you bring it up just a little higher so we can see that it does indeed cross the y-axis below the x-axis? Great, great. Okay. Thanks for reminding us about that, Mike. So here we've utilized bivariate data and fit a line to it, something that's quite easy for students to do. The relationships are what teachers then have a chance to discuss, not the mechanics. Okay.
All right, Mike. I'm sorry, Denny. How about I'm going to go ahead and pass it off to you, if that's all right, and we can take a look at some random sampling. How does that sound?
That sounds great. Okay. Well, I want to talk first about interrogating data. This is an activity that was downloaded from TI's website, the Math Nspired website, the middle school materials, and
Denny?
in particular. Yes.
Sorry to interrupt. Can you do me a favor? Make sure you're sharing your desktop. Perfect.
Thank you. I see that now. This reminds me of the time when I start talking to my students about something that's not up on the overhead, but I talk about it for a few moments, so thank you very much. I want to first start talking about interrogating data. This activity is available in the Math Nspire site. And the notion is you create a data set, or you find a data set, and it's entered into the Nspire. And what we want to do is utilize random sampling to find whether we can determine, are we getting a sample of a good enough size so we can ask questions about the entire population. There are lots of times when one does not want to go around and ask everybody certain questions or gather data that may be too difficult, especially in the election season we have now. We see lots of polls produced and the data is produced, but they don't ask everybody in the U.S. And so the notion of random sampling is something that we want students to experience. In this activity, students are given the opportunity to randomly sample data, and their sample sizes vary. And so in this, one of the issues is there's a random sample number 1. Let's say I choose to have one of size 5. Well, I'm going to press enter here. And what I'd like to do is I'd like to find how to random sample. I'm going to do it just for this one, and then later I'll show you something a little different. And I went to the catalog, and I wish it said random sample, but it doesn't. So I'm going to type the letter R, and it's going to jump in the alphabet down a ways. Now I'm moving down a bit. And here we have random sample. And here's the syntax for that. We need to find the list. We want to know how many trials. And we want to determine whether we want to do replacement or not. Well, if we leave it out, we can put a 0 or a 1 in there, but if we leave it out, it's not going to do the replacement. So let's see what happens when I click this. This one. All right. And I'd like to know the variable that I'd like to randomly sample. So I'm going to click the variable key, and I see population. The data of the entire population is here. The comma's down here. And then I'd like to do one of size 5. I'll do the comma again. And a 1. It picked 5 out of that data set. If I go back up to this, and I decide I want to change this, I'm moving down here to click. Let's say I want 4 of them. Of course, it's asking me if I want to proceed and wipe out the previous column that I made, but it's going to replace it with this one. The point of this activity, though, is to determine what random sample size you would need to make to come to understand some important things about the data. For instance, you might find the mean of the data set. You might find the median. Well, I'm going to do that for this one right here. And these we could do. And I would like to put in equals mean. And I'm going to type sample 1. Now it gives me this value. I'm going to go back and change it. And I'm going to put times 1 point. That's one way you could change those values from fractions to decimals.
Yeah, I was going to ask you to tell me why you put the 1 point, Denny.
Well,
why do we do that?
The wonderful thing about this device is if you want to cheat and get a quick decimal result, put a decimal in the expression you're computing. So I just took all of the values in sample 1, multiplied them by 1.0, and that introduces the decimal into the computation, and then it's happy to give a decimal result instead of one that's a fraction or a square root. It's just one of several different methods one could use. Now, we could do different sample sizes, and we could find out different means for different sample sizes. We could also do other computations as well. But if we want to come to understand what's going on, if we want to interrogate the data, we need to choose random samples and investigate how big a random sample do we need to have to get a good idea of what the true population's mean or median were, or some other statistic of interest. So what I wanted to do, instead of staying on this wonderful activity, it deserves its own hour. I wanted to introduce the idea of how we could create a data set. Blake, what do you think of doing that now?
I think that'd be great. How do we do that?
Okay, let me create a new document, okay? And the first thing I'm going to do is introduce the idea of a calculator. What kind of data sets do you think would be interesting? What do you have in mind, Blake?
I know that one of the things that we play with in probability and statistics in middle school are number cubes, or as they're sometimes called, dice. So could we do something where we generate some values, kind of thinking along the lines or pretending that we're throwing some dice?
Well, let's do that. There's a number cube right there. Here's one way to do it. I would like a random integer from the values of 1 up to 6, and that gives me one of them. Here I'll do it again, and it gives me another one. This gives me values from 1 to 6. Suppose I want 3 of them. Well, I'm going to use this feature of the calculator. I love this. I go up by pressing the up portion of the touchpad until I land on the expression I want. And as soon as I press enter, it copies it and then pastes it in on the line that I want to create next. Now I'd like to go inside this expression, and I can modify it ever so slightly by pressing, let's say, a comma and then a 3, and I press enter, and what I end up with is 3 values that range in size from 1 to 6. So it's easy to come up with a way to simulate rolling a die.
So in that expression where we've got rand int, the first 2 values are basically that defines the range of the values that we're wanting to generate random numbers from. And the third number tells us how many of those values we want. It's our sample size, right, Denny?
That's right. Let's try this one. Numbers from 2 to 10, and I want 5 of them. And we do get values up to the number, like we did here. In this case, we didn't get the lowest value. In this case, we did get the upper value, but we didn't get the lower value. When I first did this, we got the lower value. So you're right. Well, let's build an interesting distribution with these number cubes. Let's use a couple at a time. I'm going to go up, 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 and let's see, I went a little too far. It's forgiving. That's what I like. Let's get 3 of them. And then what I'd love to do is to get another 3. So I'm going to add these together. Oops. Happy fingers. When I press enter, it's going to create random numbers from 1 to 6, 3 of them in the first expression, the first part of the expression. Then it's going to compute 3 others and then find the sum. We don't know what values gave us 11. Well, I'm pretty sure it's 5 and 6. 7 could have been achieved by 1 and 6, 2 and 5, etc. And I could do this with 3 of them if I wish. And the nice thing about the copy-paste feature is it's easy to add on to these expressions. So here I have three values.
How are you doing that? How are you doing the copy and paste?
Well, when I move the cursor from the current line right here up, when it's highlighted, and I press enter, it does copy what I had highlighted down to the new place. So think of it as the cut and paste, but it's already reduced to just one step. So you get to it, when you're on it, you press enter, and it takes you back down to the new line right up here. It takes us, let me start again, up here. it takes us back to the line we want to create. All right. Now, if I want to do 3, this is one I like, but suppose I want to do 5 of them at a time instead. I'll change this to a 5. I went up and copied it. I'm going back and changing this to a 5. And changing this to a 5. So I now have 5 values. Well, what if I want to create a distribution that might have 1,000 of these? It would be easy to do. Let's see how long it takes. I'll change the 5 to 1,000. Instead of 5 values, I want 1,000 of them. And as instantly as I press enter, these show up. The list is so long, though, I can't see all of it. And I press enter again, and it gives me another set. Now, these values, I think, can range, let's see. The low is 1, 1, 1, so that's 3. The lowest is 3, and the highest would be 18. And most people don't know which one the most common ones are and how close they are to each other. So we could store this as well and then look at it in a spreadsheet. Let's take a look at doing that. I'm going to go up. Let's say I go up and I copy this expression, and then I decide I want to store it in some variable. I'm going to call it POP. That's short for population. And I'll press enter. And it has stored these values right here. Next thing I'll do is move to a spreadsheet. So I'm going to add a spreadsheet now. Variety of ways to do that. I'll do this one. Control and add a page. Right up here, add a page. List and spreadsheet. And gosh, if I move up to the top and name it POP and press enter, they all show up. So let me go back, control and then the left. So I've got this. Now, I'm going to do a random sample. I'm going to create one. I'll call it RS1, short for random sample 1. That's the name of it. I'll move down, I'll press enter. And again, catalog's my friend. So the last place I visited was random sample, and guess what? It's still there. So if I click that, type in, POP, and then comma. Blake, any ideas about the sample size? How many random sample size? How big you want me to choose?
Let's say 15.
50?
Yeah.
Okay. All right. And it got 50 of them very quickly, very easily. Let's say I want to examine that very quickly. I just want to get a sense of what that looks like. So notice I'm in RS1. I'm in that column. I'll go over to menu. I want to do a little work with the data. In fact, I want to do a quick graph. I love this feature.
Isn't that nice?
So quick, so friendly, so easy. And of course, let's change the plot type to a histogram. We get a sense about which values might occur more often than others. Those in the range of 10, 11, 12, 13, 14 may be the ones that occur the most. We could go back over to the spreadsheet. And let me modify this. I'm going to change it to 10. Of course, our set shrinks in size. But I think we had more information about what the population looked like by looking at a larger sample. The question always is, how big a sample size makes sense? Now let me show one other feature of this. Let me move just away from this, just for the sake of doing that. Notice I could just keep going down on this set for quite some time. And I could go over to another column as well. But I want to show you one feature that I really like. If I do Control, if I click Control and R, it randomly chooses another sample. It re-randomizes things. But let me take a look. My original population didn't change, simply because I defined it back over here. So it was defined over here. It wasn't defined in the spreadsheet. And so that's a way to protect it from being changed. If I defined it here and had the sum of 3 die defined in this formula here, then that would have changed the entire population. So here's a way we could do that. We can create a population and maybe even hide it from our students. For instance, if I go back to this page and I choose to select all of it, I'll slowly say this, Control K, it kind of changes the outline of this entire page. And if I press the delete key, oh my, it's gone. Students have no way of knowing how that population was created. It simply exists. What variables do we know about? Oops. Population is known in this document, but students can't access it directly. So it allows us to do lots of different things with data sets, to keep them hidden from students if you wish to, if you want to do interrogating data-like activities, where they don't ever get to see all of the data. Nspire allows us to do lots of neat things. This is just one of them.
Hey, Denny, I have a question. If I do an activity like this with my students and they're all getting the same results when they're doing these random samples, how can I remedy that?
Well, let's say we leave the population the same. One way to change that, if I go over and click on, I'm moving my cursor over, click on Scratchpad, and I want to change what's called random seed that allows us to change this so that everybody gets the same result or everybody gets a different result. And here's what I would do. Over here, I would do random again, but this time I would go to random seed.
So that's under my probability menu, and then I go to random, and then scroll down to seed.
Random seed, that's right. And students could press the letters R-A-N-D. They could use the, type rand seed. And here's what I recommend to my students. Choose a 4-digit number that you think nobody else will think of. And if it's your mom and dad's cell phone number or home phone number, go ahead and punch that in. So when I demonstrate this, I might use my office number's last 4 digits. And if somebody does something different than that, now I'm going to move back. Let's see. Escape is my way out of that. And again, if I press the buttons Command and R. Control and R. My Mac talk slipped in there, sorry. I'll get different values every time. And if students press in different random seeds, they're going to get different values as well. Other questions, Blake?
No, I think that kind of addresses everything with that activity. If it's all right, Denny, could you pass the control? Control back to me? I did see a question that I think is worth addressing, and I think Mike even mentioned to the person earlier. But if it's all right, Mike, is it all right with you if we move to that question about categorical data?
Please.
Okay.
That'd be great.
So the question came up earlier regarding how can we show categorical data, and there is an activity that is also available on the Math Nspired website that deals with categorical data. So I'm going to show you one way of accessing activities as I do this. For those of you that have the teacher software or the Navigator software, you have a content tab at the top, and you can click on that content tab, and then in the middle of your screen, you can actually sort by grade level or course. And so in this case, we're going to be looking at middle grades math, and we're going to be looking in the statistics and probability section. And the name of the activity that has some of this categorical data is titled Say It with a Survey. So I can select this, and I have a couple of options at this point. You can actually save it to your computer, which I highly recommend, but there's a couple of steps involved with that. So right now, I'm just going to double-click this, and it'll actually download the activity and open the TNS file within the software. Now, if we're doing this from the website, we actually have to save them from the website and then open them that way. But in this activity, students are investigating how to use bar graphs and finding patterns in categorical data, but we'll also see some other representations as well. Again, we start off with some predefined data, and what Denny was kind of mentioning in that previous activity, and I'll go ahead and talk about this now. This is a data and statistics page, and in order for us to have a data and statistics page, there has to be some variables somewhere within the document that have values defined for them already. More than likely, this was created with a list and spreadsheets page, and then perhaps the list and spreadsheets page was actually deleted from this file. So we're left with the data and statistics page, but those values and variables are still associated with one another within the file. So what I'm going to do here is I'm going to put a variable down along my x-axis, and you can see this is defined. These are defined as categorical. This is categorical data. In other words, we're not dealing with numeric values. We're dealing with some data that's defined by a text. And so we're looking at different types of music here. And we have some of the same options. Since this is a data and statistics page, I can go to menu. I can switch my plot type, but notice now I don't have the options that I had before. Because it's categorical data, I can't graph this as a histogram or a box plot. And I'm really seeing these data points, but it's not a dot plot in the sense that we were seeing dot plots earlier along a number line. But I do have some options down at the bottom, and one of these options is a bar chart, so I can select the bar chart, and it will give me the frequency for each of these categories. And these were predefined, as I mentioned, and they were also color-coded from the beginning. I can also switch this from a pie chart from a bar chart to a pie chart. I do have a dot chart option. That's what we saw earlier, but as I mentioned, it's not the same as a dot plot that's along a number line because it's categorical data. I'm going to switch this to a pie chart now.
I love the dance of those dots.
I do too. That's really pretty amazing. Mike, I'm looking at the time here. Do we have time to show how to create this, or do we need to kind of start to wrap things up?
I think we need to start wrapping things out.
Okay.
Blake, before you do, would you move your cursor over the red region?
Certainly.
And notice that those things pop up. They were popping up before. I just wanted to make note of those. These provide students opportunities to make sense of the data in a different way, and the computations are done for them. But one might ask, where do those values come from?
Well, they're coming from these variables that are predefined within this file, and they're predefined with those values. If we had time, we could actually look at this in by creating a new document or a new list and spreadsheets page. And what's nice about the software, I will mention this before we close things up. You can create this same type file, and you can actually do the quick graph that Denny showed you earlier, and your students can change the values in the spreadsheet, and it will dynamically change the bar graph and the pie graph that correlates to that data.